calculating relative humidity and dew point. So what is relative humidity? Well, it's simply the amount of moisture in the air compared to what the air can hold at a given temperature. So for example, if I were to say that humidity, which is always measured as a percent, is 100%, that means the air is holding all that it can at the current temperature. Now, we don't always use relative humidity to describe the amount of moisture in the air. We might also use something called dew point. Dew point is the temperature at which the humidity equals 100%. This is a temperature, so it's generally going to be in degrees Celsius or degrees Fahrenheit. So the closer together the actual temperature of the air and the dew point are, the more the humidity is. And if the two numbers are equal, the air temperature and the dew point, then the humidity equals 100%. But how do we calculate humidity and dew point? Well, we have to use an instrument, which is called a psychrometer. You see one here. Here's what a psychrometer is made of. It's actually quite a simple tool. It's made of two thermometers. One is just a normal run-of-the-mill thermometer. We call it the dry bulb. You'll see why in a second. The second thermometer has a bit of water on the end, which I'll show you in a moment, and we call this the wet bulb thermometer. Here's how it works. You take the end of the wet bulb thermometer and you put it in a small piece of cloth. And that cloth goes into a reservoir of water, or it's at least soaked in some water, and that makes the temperature of that thermometer change as the water evaporates. So we end up with two temperatures. We end up with the dry bulb temperature and a wet bulb temperature. Just so you know, there are other varieties of psychrometers. In fact, this one's called a sling psychrometer, but it essentially works the same way. You have a dry bulb, which is the air temperature, and you have a wet bulb, which is always going to be equal or lower. And so what will happen is the water in the wet bulb evaporates. And as it evaporates, it cools down that wet bulb thermometer. Now, how quickly it evaporates is determined by how much moisture is in the air. And so, by looking at how close or far apart your wet bulb and your dry bulb are, you can get a good gauge of how much moisture is in the air. So let's do a problem and see how this works. First of all, we can't just do this with the psychrometer on its own. We need a second tool, which is this set of tables here. You'll find them in your Earth Science reference tables. Notice we have one that's specifically for calculating humidity, and then the other one which is specifically for dew point. So let's see how we use these tables. We'll begin by taking some measurements. So step one is going to be to identify the dry bulb and wet bulb temperatures according to your psychrometer. Let's use this one as an example. If you look right here, you'll see this is the dry bulb, and the temperature appears to be 22 degrees Celsius. If we look over here at the wet bulb, we see the temperature appears to be about 14 degrees Celsius. So now that we have our dry bulb and wet bulb recorded, we have to go to step two, which is subtracting them to find what we call the depression. In this case, 22 minus 14 equals 8 degrees Celsius. Now, the next step will be to go to our chart. We have to keep in mind, we want to record what our dry bulb is and what our depression is. Those are the two important numbers. Like I said, we'll start with the humidity. So we need to look at our humidity chart. And what we're going to do is we're going to begin by looking at the left-hand column on this chart where it says dry bulb temperature. Our dry bulb is 22 degrees Celsius, so we're going to locate that on the left and just kind of mark off that row, as I did in green here. Then, step 6, we're going to locate the depression on the top. In this case, it's 8 degrees Celsius, and we're going to come down. Notice we didn't really use the wet bulb on this chart. We're simply using the dry bulb, which is the same as the air temperature, and the depression, which is the difference between the dry and the wet. Now notice how my green row and my orange column intersect. Where they intersect, that would be your relative humidity, which in this case is 40%. It's as simple as that. If we want to find the dew point, we would do the exact same process but using the dew point chart. I'll find my dry bulb on the left, which is 22, and my depression or difference on the top, which is 8. And where those two cross, we have our dew point, which in this case is 8 degrees Celsius. Now, just to put that in perspective for you, in this example, the dry bulb was the air temperature, which is 22 degrees. The dew point is 8 degrees. Now those are fairly far apart, which tells me that it's not very humid out, which makes sense because we calculate the humidity to be only 40%. One last thing to point out that's a little tricky with this chart. You'll notice the dry bulb numbers, they only include the even numbers, so they're skipping. You see -20, -18, -16, etc. If you were to get a number that falls in between, an odd number, you would be best off calculating the humidity or the dew point for the two numbers closest to the one you have, and then averaging them out. And so that's how we use our reference tables and a psychrometer to calculate humidity and dew point.